All right, so tonight I thought as we wrap up the unit that we're in, I would come up with a little bit more complicated program and give you guys an example of how to break that down. There's a few things I want to illustrate here, not just writing the program and getting it correct, which is always the goal, but breaking it down into smaller sub-problems and being able to implement them iteratively, a small piece, then make it a little bit bigger and a little bit bigger and test it as we go and make sure that it's correct all along. As programs get more difficult, based on your experience with easier programs, you can have the tendency to believe that you can just write hundreds of lines of code and as long as you're careful, it'll just work at the end. Also, you can mistakenly believe that in a large program with a small bug, it should be pretty easy to track down where that problem was, even when you have an error message that tells you what it thinks that the problem is. And that's often false. Often while technically correct, the text of the error message can point you someplace different than where the actual error originates and what you need to change about your program to fix it. So I don't know how feasible this problem is. I came up with it in the last 30 seconds before I started talking, so let's just go through it and see what we're running into here. So a farmer has a farm and he has a bunch of chickens. The chickens lay eggs. But we need to do some accounting around the egg collection process as time goes on. The IRS specifically needs to know how many eggs were collected by the farmer so that they can know how many eggs to tax them. And we'll say, just to make it easy, the IRS gets 30% of their eggs. So the program needs to ask how many chickens the farmer has, how many weeks we're going to track, because one farmer may do it 4 weeks at a time and do it monthly, another farmer may do it quarterly, another farmer may do all 52 at the end of the year, that sort of thing. So we'll let the farmer decide how they want to add up and calculate the tax. And this is kind of artificial because I just wanted to have a nested loop, if you can't tell. So for each week that we're going to process, there's always 7 days. So chickens don't get vacations. They don't take Columbus Day off and not lay eggs on that day. They just keep laying eggs. They don't know that it's a holiday. So we need to always ask for how many eggs were laid on each of the 7 days of the week. So thinking programmer-wise, that's probably going to be a loop from 1 to 7, right? We're always going to have 7 days in a week. But then once we run the program and we've asked all these questions, the farmer's entered all the data that he has from the Post-it notes or the chicken scratches or memory or however he has kept all of his records, and he's sitting here with this pile of receipts and he's running the program and he's entering how many eggs each day of the time period, then it's supposed to calculate the total number of eggs and then how much the tax is going to be. And another little added benefit there is the IRS always rounds up. So even if it's supposed to be 37.1 eggs, then the IRS always gets 38 eggs. So
let's see what it rounds up.
Okay? So now let's talk about the pseudocode. Why bother with the pseudocode? Why don't we just jump right into the Python?
Because the pseudocode is supposed to may be a format, so it'd be easier to program it, right?
That's a great answer. I wonder why so few of you actually do that then. Because one of my frequent comments on people's assignments that they submit is, it looks to me like you wrote the Python first, and then with it up in the corner of your screen, you went over and tried to hack together some semblance of a pseudocode because it was required to have it when you turned it in. Completely different purposes. If you've already got the Python, I guarantee you nobody ever has a working program and goes back and writes a pseudocode. It's not done. Okay? You do the pseudocode to get, and here's another thing. Doing the pseudocode tells me whether you went and read the assignment carefully or not. It's supposed to help protect you. When I see somebody turn in an assignment and they miss a key feature that was stated right there, you have to do this when you turn it in, and it's missing from what you turned in, my guess is that you got excited about, oh, I know how to do that, and you jumped in and started writing the Python, and you never went back and made any notes or constructed a plan, a checklist to make sure that you did everything in the assignment, or maybe even didn't read the whole assignment and just forgot. By the time you got it working, you forgot you had to go back and also add that feature, and so you just turned it in. So doing the pseudocode gives you the opportunity to make some notes. The reason why we focus on simply identifying what your inputs are, what processing steps that you have to do, and what outputs you have to print on the screen. That's the main three things that you're looking for when you do pseudocode. So if you skip that, you're losing all the benefits of it. Why bother doing pseudocode at all if you're not taking advantage of those benefits? If you already wrote the Python code and you missed the feature from the assignment, are you going to go back when you write the pseudocode and add that feature? Probably not. So it's like, what's the point? Anyway, so hopefully my comments on your submissions have been consistent with that feedback, and let's jump in. Okay, so my pseudocode's always going to have a begin and an end. Everything inside here is always going to be indented, right? Okay. What are my inputs?
You need how many eggs the farmer gets per week?
Okay. Ask how many chickens.
Okay. How many weeks?
So that sounds to me like an input, right?
Okay, so
How about get number of chickens from farmer? Or we can just say user. What's next?
Get how many weeks?
Get number of weeks.
Get number of weeks from user.
Why does someone put a week and a half? Good question.
If you had a week and a half, how many days are you going to ask for? Doesn't help us.
A week and a half, so like a week is 7 days. Half a week is like 3 or 4 days, so like 10.
3 or 4. The computer doesn't know. 3 the first time, 4 the second time. Should I calculate a random number and sometimes do 3, sometimes do 4? This would be an opportunity for a clarifying question. If I had said for you to do 3.5 weeks, you would say, excuse me, but no, that's why we don't do half weeks, is because the week we already said is assumed to be 7 days.
Yeah, that's a prime number.
And then the next thing here in our specifications is how many eggs each day of the week.
And how many eggs from one day?
You go get that number soon.
Each day, yeah, each day. That implies that there will be more than one day. Is that can have a different number of eggs on different days. So you could perhaps assume, if you were trying to take liberties, right, you could make the farmer do the math in their head, right? You might be able to try that and get away with it when you turn in your assignment, but probably not. What's more likely is for each day of the week, 7 of them, get number of eggs that day.
Are you going to use a for loop?
I don't know. We're doing pseudocode yet. I'm not worried about the code yet.
Okay.
We're just trying to what? What are we trying to identify?
The amount of
Total
eggs
amount.
each week. I mean each day, not each day.
Oh, higher level.
Each month?
Inputs, processing steps, and outputs. That's all we're really focusing on, because we don't want to miss any of them. That's why we're focusing on it. We're not jumping to the Python. We don't want to miss any of our inputs, our processing steps, or our outputs. Okay, at the end, it should print the total number of eggs. So at the end, that's a clue down here. Print total eggs, calculate the tax. I assume it doesn't say, but print the tax. It'd be silly to calculate it and not print it. And I might want to say here, since it explicitly says something about rounding and how to calculate it, that I make a note of that in my pseudocode. So now I'm not liable to forget that specification.
Could you put the percentage symbol for the round so you remember you have to use that for your code?
Is that rounding? I don't think percent is rounding. I think percent is modulus.
Get the ceiling value? Get the ceiling value? If you're rounding up.
Yeah, when we get to that point, maybe we'll look and see what Python functions we have for doing that kind of thing, for rounding. Okay, did they talk about rounding in the textbook or in the Codio exercises?
I don't think it got there yet. The only thing that got close to was that the percentage is the percentage of a number or the remainder.
Okay, so in between here, so we've got our inputs and we've done our outputs, but it was kind of vague in the instructions on what to do in between there. So it says to print the total eggs, but how do I calculate the total eggs? We didn't ask the user for the total eggs, so I presume we're going to have to calculate it.
So we number of chip, no. Number of weeks per user.
It looks at
It'd be the number of eggs times the days of the week, right? So it'd be however many eggs you get daily times 7.
It would be if we had the same number of eggs each day. And are you feeling any kind of parallels between this assignment and the temperatures assignment? Maybe thinking that that's on purpose because they're similar and I wanted you to have a good example of a harder assignment?
It makes it sound like you're asking the user, because it's like how many chickens, then how many weeks, and then how many eggs per day. Is that per
Yes.
chicken maybe?
So, are we just gonna like multiply the 3 numbers or something?
Could we multiply it if it's a different number every time?
No.
Or could you just get the input 7 times and have them input 7 different numbers?
Yes.
Oh, yeah.
Or, that's like
Yeah,
something
that's what we're saying here with the, for each day of the week, get the number of eggs that day. So we're going to be asking in a loop. So I guess the thing I'm trying to point out here, the concept is add daily eggs to weekly total. Which, I mean, I'll just tell you, if you're going to have a weekly total, we don't have to set it to 0 to start with. And then each day we ask, okay, 2 eggs this day, 7 eggs that day, 9 eggs the next day, 4 eggs the next day. They enter how many eggs each day of the week, and we add them to the total. So now when we get down here, we now know how many eggs there are for that 1 week. How do we get the number of eggs for the next week? You know, if the user entered 4 weeks, when we asked them, how many weeks do you want to do? We just did 1 week. How do we do the next week?
Unnecessary loop.
Another for loop for each week.
So do a nested loop.
And now I have to indent all these lines. Okay, so then this loop loops, let's say they entered 4 weeks and 10 chickens. And we've got 7 days. Okay, so for week number 1, we go through and we ask 7 times, how many eggs did you get this day? We add that to the total, and then on the 7th day, we enter a number, and this nested loop finishes. where does it go?
Goes back into the outer loop.
And when I say it, I mean the execution pointer, the next instruction to execute. It doesn't come down here to print total eggs. It goes back up here to get week number 2. So I set weekly total to 0, but wait, that was holding the data for week 1, and I'm just setting it back to 0.
You'll store it somewhere.
Initialize it before you enter the week.
Yeah, so that sounds like I need another variable. Set, actually, I haven't really used the number of chickens, have I?
No, I don't think so.
So maybe that's irrelevant.
Yeah, because I didn't think that really mattered.
Maybe it'd be like if it was more complicated, maybe it'd be brackets. Like the more chickens you have, the more.
Or how many chicks, or how many eggs per chicken too.
Yeah?
Yeah, but they're not asking that.
So this is one thing common with reports, especially government-related reports involving accounting or taxes or whatever. You can have 2 streams of stuff going on here. On the report, like you're looking up some Form 27/C from the government, and it says your form will say how many chickens, how many weeks this cover, how many eggs, total, average number of eggs, how much the tax is going to be. It lists all those things. So even if the number of chickens is irrelevant for our calculations, it's not irrelevant for producing the output required for this program. So we're not just going to delete this because we don't think we've got any place to use it. We still might have to print it down here, even though we didn't say. So a clarifying question might be, hey, how come we asked for number of chickens, but then we didn't use it anywhere else in our program? And I say, oh, you got me. I meant to say print number of chickens at the end. Okay? Now we're all good. Now we're asking for it. We're not using it in our calculations, but we are printing it. That's perfectly fine.
Okay.
So up here I'm going to say set total eggs to 0. And then after the interlude finishes, I'm going to say add daily eggs to total eggs. Everybody still with me?
Yeah.
Now, this is not Python, it won't compile, right? There's problems that, with programming I have to figure out still. But, yeah, this doesn't look too bad for pseudocode. Gives me a roadmap. Okay, so let me move this over here.
Should we calculate the tax before we print stuff, or is it just like?
Well, we said calculate tax. Okay, so the pattern that I told you earlier, in general, we always want to try to do our inputs first, then our calculations, then our outputs. That is definitely true in general. It's not illegal to wait until the last minute to calculate the tax, that's okay. But point taken, perhaps we want to move this up higher. Sure.
Calculate.
So that's perfectly fine too.
Okay, but the tax will be like eggs or actual money, because it doesn't do it in the code, in the directions. It really doesn't say.
I guarantee you, to the farmer, it doesn't matter.
Okay.
It's still fewer dollars that he gets to decide what to do with, so. All right, so now we've got our Python. Let me make this bigger. All of that stuff we put in there that we're supposed to do.
Right.
I need to print my welcome message, right?
Yeah.
Yeah. Welcome to the egg calculator deluxe.
Egg tax. We forgot the tax bit.
Then
And then at the bottom, should I go ahead and put my,
print, I'm pretty sure it's INT if you, oh, no matter. You say thank you. My bad.
okay, so I've taken care of the boilerplate stuff.
You need to get the number of chickens, so I'm pretty sure it's, you could say my string equals, INT, chickens.
Yep, this is all stuff that you know how to do. You're right.
And put,
Chickens.
Like a fly on your hand?
then you need to put, number of weeks for user. Wouldn't it be better to use floats instead of integer?
You tell me. For the number of chickens, can I have a decimal number of chickens?
Yeah, you can cut the chicken in half.
Well, it's gonna produce half as many eggs.
I can predict how many eggs half of a chicken is going to produce. Pretty accurately. So now we have our inputs. You know, I could even be a good student and put inputs there.
Then you need to set total x to 0, so you gotta put x equals 0.
You know, and you sound like an expert Python developer. Why? Because we did a great job of creating our pseudocode, right? See how much easier it is and how smoother it flows when you already have a plan, right? I'm just saying, I'm putting the sales pitch out there for pseudocode. People ask, why do I have to do this pseudocode? The hardest part is the pseudocode. Well, okay, next. You said set total x to 0?
So x equals 0, total x to 0.
Okay,
Then you have to use a loop, outer loop to begin with.
okay, I'm just gonna say outer loop.
But for each day of the week, you can use 4. For I,
Okay, we talked in the lecture recording about indefinite versus definite repetition, right?
yeah.
Remember the difference between them? Definite versus indefinite?
Definite is when you know how many times, indefinite is when you don't. The user needs to decide how many.
Yeah, and even more specific, because we may know at a certain point how many times it's going to loop. But like at the very beginning, do you know how many weeks the farmer is going to enter?
No.
Is he going to enter 12? Is he going to enter 52? We don't know. But at the start of the loop, we do know, because the input statement has already occurred. So that can still be definite repetition, because when at the start of the loop, we know how many times it's going to execute. And that allows us to use a for loop if we want to. We don't have to, like we said, any for loop we can do as a while.
Yeah, because a while loop is better, you have more range to do things, it's more customizable.
Yes.
But for a for loop, you have to put like a certain number in order for it to work. So a for loop wouldn't really work for this, would it?
Yeah, for loop only works when you have a number that you want to count.
Which technically, because we have that, that's what we do. So you could do for I in range of 1, 2.
I, is I a good variable name?
J?
I will allow something like index, because you're telling me that the purpose of this variable is to be indexed into the number of weeks, right? But why don't we just say week?
Okay.
Yeah.
Okay.
And where do we want to start and stop?
It start at 0 and stop at...
One,
Yeah, Sunday.
and then you do weeks. And this was messing me up. And you do +1 because you don't do +1.
Yeah.
This is all the very, very deep Python stuff that we just, as Python developers, we have to know. When I'm doing a counted loop, I go from 1 to how many times +1, or I go from 0 to how many times. You can do one or the other, but not both.
Because it starts at 0.
It can start at 0.
But then you gotta pay attention. to
If I
what
say-
it is.
0 to weeks, that is also fine. It's only going to loop that many times. But if I say 0 to weeks +1,
Extra time.
it's going to be too many. If I do 1 to weeks, it's going to be 1 too few. And that's what we call, what kind of bug?
I think it was an initial error or something? New numbers?
Off by 1.
Off by 1 error.
Yeah. Those are very sneaky and they can be insidious when you're trying to debug something and figure out why your program isn't working, why you're not getting the right results.
Set weekly total to 0.
Yeah. Weekly eggs is 0.
Then we have to... then we have to do the inner loop now.
For day in range 1 to
See, you guys are just great when you've got the pseudocode sitting there, right?
1 to, I guess that'd be
For day, in, range. How am I going to do this? How many times do I have to loop? How many days do I have to loop?
7.
7. So am I going to go
1 to 8.
1 to 8?
Okay, because
Yeah, because I don't think it counts 8. It stops at 7.
Yes, correct.
Yeah.
I do have a question though.
Yeah.
For the weekly eggs equals 0, initializing that variable to 0, if we're doing a for loop and it keeps iterating through and you're going across multiple weeks, won't that just keep setting the value to 0 and
Yes.
make it inaccurate?
No. Yes, it will keep resetting it, but we're only, this inner loop is only counting the number of eggs in 1 week.
something calculated.
Remember, and then at the end of the loop, we add that daily, well, I guess this is a misnomer actually,
Oh, yeah.
because this is the weekly eggs.
Or,
Yeah. Add the weekly total to the total eggs. So that was just a little bug in our pseudocode.
well, wouldn't that be, oh, wait. Yeah.
Where this loop is calculating the weekly total. How many eggs do we get that week? So at the end, we had that weekly total that we spent all that time in that loop getting, and we added to the total eggs, the outer loop. The outer loop is calculating the total eggs, the inner loop is calculating the weekly eggs.
Okay.
Okay, so now we're on the inner loop. What am I going to do here?
Ask for the number of eggs that day. Should we maybe should we have a message saying this week, this day or something because it'd be kind of confusing if we were just what's this, ask
That's a
another.
great question. Maybe we should use an F string inside our input statement.
Oh, so it will show it in the, show it to the program in the shell. It's a...
Yeah, I guess if we wanted to make it even more complicated, we could use an array and have the day go to an actual a string.
Yeah. So I wouldn't do that because we haven't talked about collections yet.
Yeah, because array is next week, but that's...
Also, for this particular problem, I wouldn't do that because there's no reason to store the number of eggs. This is one of the big things I see with the temperatures program, is people jump ahead and they read about collections or arrays, or they've played with them before, and they think, oh, I need to collect each temperature in an array, that way later I can sum them up. No, you don't need to. There's no reason to keep it. After you've added it to a weekly total, there's no reason to keep it anymore. right?
Yeah.
Okay, so that's a very good point. I probably would have missed that, but since you pointed it out, we can tell them, hey, this is day number 1. If we wanted to be even fancier, we could come up with some Python way of saying it's Sunday. How many eggs did they produce on Sunday? How many eggs do they produce on Tuesday? Whatever.
Then we had to put Monday, Tuesday, like the days of the week.
We would, yeah, if we had to do that.
Okay.
Yeah. I'm not going to stop and do that right now, but yeah, if you want to replicate this yourself and figure that out, that'd be a fun little project, wouldn't it?
That's
Okay, so now I've got how many eggs were produced that day, and I want to,
Add daily the week, oh, I know.
Wait, what does plus and equal sign?
we have plus equals in Python, don't we?
Yeah, I'm just saying, what does that mean again?
It's adding eggs to the weekly, instead of doing a new variable and then doing weekly eggs plus eggs and then assignment.
Yeah, it does the exact same thing as this.
Oh, okay.
That's
My bad.
That's great.
I did.
I was just trying to be fancy and use Python stuff.
I just do the most simplest version.
It's all good.
Okay, so now when this loop finishes, we have how many eggs were produced in the week stored in this variable, right? So now we get outside the loop. What do I have to do?
Indent once.
Ah, man, you're slick. I was gonna not indent it and try to see if I could catch you guys. But, yes, total eggs plus equals weekly eggs. Yeah, what would have happened if I had not indented that and I'd have done it here?
It would have, like, you would have not had the data for all the others except for the last one.
Exactly. Did you guys catch that?
Yeah.
What that would have produced is my total eggs would have only counted up the last week's worth of eggs. Because it would have been after the outer loop finished, not after each time the inner loop finished.
Yeah.
Okay.
Their farm would be arrested for tax evasion.
And it's a customer, so we don't want that. We want the customer to be happy and keep buying our software.
Now we need to calculate the tax. Yo, the tax is 0.0001. Wait,
We're doing 30%, so 0.3.
30%, okay, yeah.
Yeah, that's another good thing. Whenever the assignment specifies a value like that, it's often good to copy that into your pseudocode so that you remember it.
Okay.
So when you get to the calculation, you can refer to it there. I missed that the first time, but it's a good thing to just note that, because these are your notes that you're going to use to inform your Python code, so.
I'm pretty sure you calculate the tax outside of the loops.
Also, how much is each egg? How much money does each egg cost?
Yeah, we don't care, it's however many eggs.
Are we taking into account how much eggs cost right now, or?
No, we don't care about that.
Until the money.
So
If it's $10, they're going to take 30% of however much it is. If it's $5, they're going to take 30% however much it is. So we can calculate the tax in eggs. For all I know, some guy in a funny suit's going to show up every, quarter and with a pickup and say, hey, load up my eggs.
So for egg tax, you do total eggs times 0.3, right? And they give you 30%.
well, you could do that, but I'm pretty sure you could also do the percentage.
And then round and then comma.
And we want to do, we want to import now, so we can do ceiling. Because we want to always round up. If I round, it would go round up.
No, but you can also use the percentage sign to do percentage. There's a circle slash zero as a circle. Because I use that as we made it and as a percentage and the Codeo assignments. Rounding.
Yeah, let's just go read about it and see what it says. Okay, if I have a number round, and I want to round it to 2 decimals, I give it the number, and I say 2, and what do you think this is going to produce?
5.7.
5.7.
Oh, 5.7.
But you said they round no matter the number, so
Could you then have it just round up now?
So if I have 37.1 eggs,
That's a comma.
if I have 37.1 eggs,
37.
but they go put 30.
37.10. I don't know, it doesn't do the zero.
Okay.
yeah, so it sounds really tempting, doesn't it? But round probably isn't the function that we want.
Yeah.
You know?
No.
Because when we read it, it says, returns a floating point number that is a rounded version. So they're defining rounded very specifically here. Rounded means if it's 0.5, it goes up. If it's 0.4, it goes down.
Yeah.
That's what they mean by round. So yeah, that's probably not the one that we want. Is there a C also? Let's see, built-in functions. You mentioned it earlier, right?
Yeah, it's, in the math area, you could find it.
See anything in there that looks interesting?
It's probably,
I don't see a ceiling function.
that's weird, 'cause I see it on the wiki and stuff.
Yeah, maybe Python math.ceiling.
Well, it's just seal, it's not ceiling.
Seal.
Seal.
Yeah, ceiling, it's structure seal.
Okay.
Okay, so 1.4 goes up to 2.
Yeah.
5.3 goes up to 6. Negative 5.3 goes to negative 5.
Well, you have to input math.
Yeah. What format?
Yeah, so that's possible. So I will, I'll give you a little trick. So basically, when I started programming, we didn't have all these fancy math libraries and ceiling functions and all this kind of stuff. So if I wanted to round something, then I could do this trick where I said, x equals, because the way it is right now, this is going to be a float, right?
Yeah.
So I could say rounded equals int
Oh, yeah.
Oh, because it always makes it round up.
Or, yeah, even if it's,
Yeah, so that's basically what the round function is doing, right? But their little .02, or their .2 parameter just says, okay, if I want to round it to 1 decimal place, I'll do that. If I want to round it to 2 decimal places, I'll do that. So that's all the round function is doing inside.
Oh, wait, question. What happened if the answer was like 2.6 and that's just adding 0.5? Wouldn't that make it rounded like 2 up when it should only round up 1?
So because then it would round down from that to the number that we want.
Yeah, this is an interesting problem, isn't it?
Because then when you go too far to where it goes all the way up to like 0.5 of that.
If you didn't have the math library and you had to implement ceiling yourself, how would you do it?
Can you use if statements at all, or?
Sure. You can implement it however you need.
I was thinking about it, it sounds like if statements would get,
You could log the number by 1 and check if it's over, if it's greater or equal to 0.5, and then add increment by 1, then increment by the floor. Or I guess you wouldn't want to use the floor, you could, like, I don't know, yeah, I guess that would be a little
well, if
complicated.
we're always rounding up to, no matter how much is after the decimal point, so it could be like 15.01, we want to do 16. So you can do, I don't know how you apply
How
it.
about, rounded equals, we'll just get the integer version of egg tax, and then we'll say if egg tax equals, or I guess we want to say not equal,
Okay.
so we add 1.
Could you do it in a Boolean expression too, so
Yeah.
that a tax were,
Yes.
okay.
Wait,
Well, wait, okay, could you use that with the float though? So if a tax equals float value, right, then do the,
Yeah. There's different ways you can do it, but I like the way you guys are creatively trying to figure out, yeah, I could just use the library function, but how would I implement it if I didn't have the library function? That instinct is going to help you. But yeah, right here, I could just say math.ceiling.
And then implement it.
and then for that,
Yeah.
it just makes it easier, but
but then there's cases, like I've run into this on my laptop sometimes, is there's a lot of times you can't even import libraries, or if you have to pip install something for a library, it won't let you pip install, so you have to
Yeah.
figure out how to do it without libraries.
Yeah, I'll tell you something about these libraries we didn't really mention when we were doing the MP3 program, but, somebody wrote that library. Now, math is written by the people that write Python, so it's pretty reliable, but there might be some other library, like that ID3 library. We don't know who wrote that, who maintains it, and the version of the Python language keeps moving along. They keep updating it, fixing bugs, adding features, etc. And you get to a certain point where, well, maybe they changed something in Python, the language, that ID3 doesn't support, and it's broken, and they haven't gone to fix it yet. So you're using Python version 13.7, and ID3 library isn't supported. It doesn't run on Python 13.7.
so basically
So you can't use it.
some libraries don't support the newest
Yes.
language.
So it would be better to go through and actually create a module.
It's something to consider. I mean, some companies say, no, I don't want you to implement it yourself if there's a library function available. Why? Why would we want to rely on the library function instead of just doing it ourselves?
Because I guess it will make it easier and faster, more efficient.
Okay, I like that. It reduces the number of lines of code in my program if I use their program, if I use their code. That's a good point. But also, theirs has probably been tested. If it's a public library, there's probably a lot of other Python developers out there using it, So it's probably been tested and verified by somebody before you got to it. So perhaps it's more reliable. And maybe your company wants you to not always re-implement it or reinvent the wheel yourself, because then you introduce a lot of bugs that wouldn't otherwise be there if you were using library code. It's one of those business decisions that people make, and if you do implement it yourself, you should probably run that code through some test cases by itself and make sure that what you did was correct. I just told you the little adding 0.5 thing was a trick, but am I right? I mean, you trust me because I'm sitting up here, right?
Yeah.
I mean, it makes sense, looking at it, and thinking about how it would work.
Yeah, because you don't know, maybe me and the other teachers are like, you won't believe what I got them to believe was true the other day. All you have to do is add 0.5 to it, and that's the same as rounding. Nobody questioned it.
No, they say the minions is real.
The what?
The minions are real, guys.
Okay, so we calculated the tax, we think. We get rid of this. Now we need to do our outputs. We're to the fun part. Print the number of chickens.
I would press add a comment.
Huh?
Add a comment.
Oh, okay. What do you want the comment to say?
Printing values?
Oh, no, outputs.
Yeah, outputs, outputs, that's a good one, yeah.
Okay?
I mean, can we use an F string too? And then just,
You put it under the thing.
The string, just put string, just do all of them in one line.
Well, we can,
seconds, and then switch is, well, you gotta put the F at the beginning of the string.
Yeah, that's
You
right.
guys are good. Chickens. Chickens.
Wait, question. Would putting number of chickens and putting the chickens inside those brackets make the program confused or?
That's what the F string is for, so that you can just put your variables.
Yeah, I mean, you can do the same string too, and just use a new line character, / new, and then keep going to the same string.
I mean, it might be hard to read maybe later on if you,
Yeah. But I could have said, common chickens. That would work too.
So if you do that, then you just add comments on this, just to kind of keep it a little bit organized.
Yeah, but we like F strings.
yeah,
so
the F string would also be nice if like you add like a amount, like if it was, I don't know, like, if it was like money, then you add like euros or whatever.
Sure.
Then you could put like /n, and then say number of total eggs.
Yeah, what is the next one? Total eggs?
Yeah.
What was our variable?
I think it was
Total
eggs. Yeah, total eggs. Then print tax, I'm pretty sure it was egg tax. That was available, like a map. Well, together? Yeah, together.
Okay.
Run it.
Okay, that looks pretty good, I think. I mean, I don't see anything that I left out from the assignment. I've covered all the stuff in my,
You forgot to put beginning and end.
like I pointed out before, the reason why I do this is not just because I'm corny, or that your boss will ever ask you to do this. In here, I do it because of things like these nested loops, where the indentation matters, and messing up the indentation can cause bugs, because I want you guys to see that this is indented specifically for a reason, to execute that loop, but then the loop ends. And we have an instruction we still need to carry out after the loop ends. So life does go on after this indentation. And that's what I wanted to point out here. So the reason why I make you do this is at the end of your program, all of your nested things, they close up and finish, and then you still need to exit out the bottom of your program. Again, for structured programming. I know many of you use that sys.exit pattern, and I'm not a fan of it because it's not structured programming. Anything that you can do in an unstructured way, you can do in a structured way. And that is thanks to these really smart computer scientists back in the 70s that proved, using a mathematical proof, that anything that you can do without structured programming, you can do with structured programming. Thank you. So there's no reason not to do things in a structured way. That allows things like Flowgorithm, because as we've discussed, before, Flowgorithm won't let you do unstructured things, right? Python will, but Flowgorithm won't. So that's, just like the benefits of doing the pseudocode I was talking about, if you put your algorithm into Flowgorithm and you figure out how to get that to work, it's really hard to then transfer that to Python and do something unstructured. It makes you do it, makes you think about that.
So for system.exit, right, like say you were writing a program where you want to give the user an actual out, and give them an exit door, like let's just say that they get to inputting the amount of weeks that they want to do their calculation for, right, but they're like, I don't want to use this program anymore, E to exit, right? how do you actually get the program to, stop and shut off and actually exit?
Great question. So we know that we can do that with a sys.exit. Right, but if we didn't want to use sys.exit, we do it just like we've done all of our other outer loops, right?
Even break.
Or one below,
Remember?
is return type?
Go again equals true, while go again, indent everything that we want inside the loop, and at the end,
Okay, so
go again equals input. Right?
right.
And instead of, I always do this, I always say true, and then I come back up here and say, go again equals yes, while go again equals yes. And then they input another one, and right here at line 32, at the bottom, it doesn't go down to the print, it goes back up to the while. So, didn't have to use sys.exit. All I did was grabbed all of this code and indented it and wrapped it with our standard normal outer loop logic. Set the initial condition, check the condition, and modify the condition somewhere in the loop. Remember the three parts of a loop?
Okay.
But,
And now it's a structured loop.
so if it puts and, it would just say, thank you for using ECD or version 1? Okay.
Yeah.
So for something like that, you do, if you do your exit keyword and so if go again equals n, then break, right? And then it exits. Okay, this makes so much more sense because I remember seeing in one of the assignments, bonus points if you could add an outer processing loop that lets the user exit.
All right, all it takes is 3 lines of code.
Well, how do you break this again? Because I know he said go again equals n. I'm thinking just click enter then say break, but I think I'm missing something with that.
Well, we talked about a different pattern. While, we can say, where's my mouse? If we get rid of this and we just say while true, remember we talked about that pattern?
Oh, yeah.
And then down here we can say if go again is not equal to yes, when we say exit.
Okay.
But if we were doing structure code, then we'd just do break.
But then I would skip.
Well, even break is not technically structured.
Really?
Yeah, it's an abnormal exit to the normal flow of the loop. So by definition, it's not structured.
Okay.
Well, what you would want to do is, again, set a variable to say, right, equals true,
So that's your loop control.
while I still want to loop. And down here, I would say
Still want to loop, no?
equals false.
Yeah.
That would be the structured way to do that.
Is false lowercase or capital?
Right? Set the initial condition, check the condition, modify the condition.
Okay, but why is it false down there?
Because that says no, I want to keep looping.
So if they put and, it will just say thank you for using, okay.
Okay, so should I actually run it, or you just want to trust me that it works?
I guess it's a little.
Debug process, let's see what it does. It's a learning process. We don't. Here we go.
How many chickens? 51.
Kind of small.
12?
Actually, I guess it's
About 12 chickens.
I guess it doesn't.
How many weeks do we want to do?
Every single one, we don't want to spend
How
hours.
many weeks is 7? That's like a third of a quarter or something, or half a quarter. We'll do 4 weeks.
Okay.
Day 1, how many eggs?
We got 7, all right, those chickens have to,
I'm just gonna randomly put,
Yeah, hopefully it's.
because these numbers do not track.
so come back to day 1 again.
Goes back down. So you could add weeks to the S string.
That'd be a great idea.
Three.
I would say week. Yeah. Okay, let's do it again. How many chickens? 12. How many weeks? 4. Week 1, day 1, how many eggs?
That's some good data right there.
Week 2, how many eggs?
12?
Notice how we're not really getting any feedback here either.
Well, it has to be week 4 yet.
I know,
Oh, yeah, maybe we could add.
but it's a little unsatisfying.
Or maybe after every week we said a total, a weekly total.
Yeah, and I mean, I'm throwing a bunch of stuff at you guys, I know this, but, you know, for this interlude, whenever you stop and do a total, and, you know, we could put a print here that says,
Subtotal.
And then the amount.
something like that.
Yeah.
And what we call that is a control break. We're doing something in the midst of our processing. I mean, I guess it's not technically. A classic control break is something like back in the old day when we printed lots of paper reports. You'd have, let's say, a report of, you're printing 1,000 lines of data. But each page can only take a certain number of lines. But what the manager would want to see is a subtotal per page.
Oh, yeah.
And so artificially, if the number of weeks or the number of farmers or whatever, you would have to stop every so many lines of code and produce a total and print that at the bottom of the page in the footer. That's like your classic control break. So this is kind of sort of a control break, but we'll see how we get along here. Okay, how many chickens? 12. How many weeks? 4.
Number.
15.
Okay, well, we got a little bit of information. So it's okay, you're up to 20 eggs.
Oh, okay, that's more satisfying.
15.
Don't get very
Next week is 29 eggs.
3. Just kidding.
23. 9.
Nope,
1.
Whoa, chill.
Remember, chickens 12, total eggs 89, egg tax 27.
But egg tax,
Do you want to do this again? No. Thank you.
Sounds all right, yeah, 20, yeah.
My only question, and this is actually the exact problem I was running into on the temperature program, right, is every time I wanted to actually print out the average temperatures, right, I do, you know, say you want to get the average temps across 2 days for 3 stations, right? You go through your first iteration, you get your 6 temperatures, your max and your min, and then you print out whatever the nighttime minimum and the daytime maximum and what the average is, but then it goes through the iteration again, and by the time it prints again, the value it's wrong, it's not.
Well, I would say, are you resetting your counter, your accumulator variable? Are you resetting it each time you go through the inner loop?
So then that was the other issue I was having, because I had my min and my max, I initialized them to 0, but then at the very end of the program, I gave the average maximum across all data, and then you know, for each station every day and doing a quote for that.
I'm giving the maximum as so the minimum should probably be a really high number at the start, like initialize it, so that any number, even if it's like, because if it's like, if zero isn't part of the data, it would mess it up.
See, this was